Welcome back, botanist. Get out your lab notebook, those colored pencils, and let's get to work, shall we? So today we're moving above ground. We've been talking about roots. Now we're going to start talking about something that we call the shoot. Let me just start screen sharing with you and talk about what I mean by that. So in botany, when we use this term shoot, what we're referring to is we're referring to the entire above ground portion of the plant. Right, the other main part of a plant being the root system. The shoot is going to be above ground. And if we think about how it functions, well, above ground is where photosynthesis is going to occur. There's also going to be a lot of support. There's going to be conduction. And reproduction is going to be occurring in the shoot as well, right? If you think about where you see flowers and cones and things like that. Oh, hold on, I'll be back. All right, I'm back. So it's in that shoot system where we're going to find reproductive structures, things like flowers, cones, right? We're going to be seeing that in the shoot system as well. Now, today we're going to be talking really about external features that we can see when we look at the stem. The reason we're doing that is that these can be really, really useful in helping distinguish between different species. And you can learn to read a lot of variations so that you can even identify species without ever looking at things like flowers or fruits or cones, right? You can just read morphology. Well, let's think about the stem. We're going to make a little drawing here of a stem. This first drawing of a stem is going to be very sticky, and by that I mean it just looks like a simple stick here. Right, that's my stem here. And what we're going to see when we look at the stem, it's going to be segregated into what we call nodes and internodes. And a node is really just a portion of the stem where a leaf attaches. And so if I look at my little stem here, I'm going to add a node. I'm going to draw just kind of a boring leaf. Right there. That would be a node, an area where a leaf attaches. Well, let me add in a couple more leaves. Right, this would also represent another node and another node right here. These areas in between, right, in between our nodes are what we call internodes because they're in between our nodes. So an internode is going to be in between those nodes and no leaves are going to be attached. Right, that'll just be in between our nodes. Now, one final thing that I want to add to this drawing is that in this little angle, in between the leaf and the main stem, is where we're going to find what we call axillary buds. An axillary bud is really just an area for future growth. We're going to be talking about this soon, right? How the shoot system elongates, how nodes and internodes and sections of the stem get produced. But those axillary buds are going to be areas where that stem system is going to elongate. So I'm just going to add a little axillary bud there in red, right in that angle. And I'm going to do that with all my leaves. Because all of our leaves are going to have axillary buds or what those axillary buds grew into. So they might have grown into a branch. So you might see a branch point in that leaf axil. Or you might see, say, a short branch with reproductive structures like flowers and fruits attached to it. This is kind of just basic stem morphology. Now, if you're learning how to identify different plants and look at their features, one of the first questions you answer about them is how their leaves are arranged. And so often if you're reading guidebooks, right, looking at the leaf arrangement is going to be one of the first questions you answer. And a lot of plants are going to have what we call an alternate leaf arrangement. And in an alternate leaf arrangement, there's one leaf per node. And that's going to be just like that kind of simple drawing that we just made, where I've got a node, there's just a single leaf at every single location. And remember, each and every single one of those leaves is also going to have a tiny little axillary bud there, right? So just one single leaf at every node. Well, other plants are going to have what we call an opposite leaf arrangement. And in an opposite leaf arrangement, we're going to find two leaves at every node. So let's make our very simple model of a stem here. Right, there's my stem. I'm going to draw a node, and I'm going to have a one leaf coming out on that direction, and then opposite on the other side of the stem, we're going to find another one. Each of those leaves is going to have an axillary bud. So make sure you give an axillary bud to that one and to that one as well. The third and the final leaf arrangement that we can see is what we call whorled leaf arrangement. And this turns out to be the least common of the three leaf arrangements. In a whorled leaf arrangement, what you find is you find 3 or more leaves at every node. So I'm just going to put 3 plus, because it might be 3, it might be 5, it might be 7. If we classify a plant as having whorled leaf arrangement, that just means there's 3 or more. Well, let's model that as well. There's my stem. I'm going to draw a node. I'm going to have one leaf coming out right here. One leaf coming out right here. Another one up there. Maybe one more right there. So I've got these 4 leaves coming out at this one single node. Each and every single one of them is going to have their own axillary bud. So make sure you give each and every single one at the base of those leaves, right where they're attaching to that stem. All right, and we're going to be practicing leaf arrangement. We're going to be seeing a lot of diversity of this in the coming weeks. Well, now I want to keep on thinking about the stem, right, and these external features, and imagine something a little bit different. What I want you to imagine is I want you to imagine a tree in winter, and I want you to imagine a tree that's what we call deciduous. A deciduous plant, or a deciduous tree, is going to be a plant that loses all of its leaves on a seasonal basis. And when plants lose their leaves, it's typically in winter, right? In winter, deciduous plants are going to shed their leaves. They're going to be what we call naked in the sense that they don't have any leaves attached to them. And you can see these kind of leafless twigs. So I want you to imagine a plant that's deciduous, that's lost all of its leaves. And we're going to be making a drawing showing that kind of woody stem morphology. We're going to be making a drawing or a model of this woody stem, seeing all these features that we can read externally, because there's a tremendous amount of information that we can read when we look at these leafless twigs. And, you know, as I've said before, you can use that morphology really to identify plants. Well, I'm going to be making a drawing. I'm going to kind of draw my stem here in the center of my drawing, and I'm going to label it on both sides. So give yourself some space when you do this. And I'm going to start by just drawing something like this. We'll add in some things as we go along. And my bottom end, I'm just going to kind of cut it off here. Now, this is just a branch that we're imagining that I kind of pruned off of a tree here. Okay. I'll get to that in a minute, but let's start by segregating our stem into really nodes and internodes. Remember, nodes are going to be areas where leaves attach, and internodes are going to be areas in between where those leaves don't attach. Well, even in winter, right, with this leafless twig, we can still find our nodes and internodes. Now, we can't see our leaves, but we can find our leaf scars. And those are just scars that are left behind, and we can find them externally on our stem here. So I'm just going to draw a leaf scar right here. That's showing us where our node is. I'm going to add another one right here. And another one right here. But they're just going to be all along my little stem here. Right? That's just showing us our nodes and our internodes. So the leaf scars are going to be where our leaves attach to that main stem. Well, when we look inside them, we can actually see tiny little scars within the leaf scars. So I'm just going to draw some little circular structures in here. Their shape is going to vary, but what these are what we call vascular bundle scars. And we're going to find these inside of our leaf scars. So that's what all these little tiny things are that I've drawn inside my leaf scars. Now, when you see vascular bundle, you should think vascular tissue. You should think xylem and phloem. This is literally a scar between the connection of the xylem and phloem that was in the leaf and the xylem and phloem that's in our stem. So you can see those within our leaf scars. And there's going to be variation in those, both in their number and their shape between different species. Well, something else that we have to add to this little model for our woody twig is, remember, all of our leaves are going to have axillary buds. So I'm just going to add a little axillary bud right there. Remember, these are going to be areas for future growth, right, for branch points. I'm going to add another one right here, another one right here. And this one up here, I'm just going to draw kind of having grown into a branch, right? That's just where an axillary bud is already elongated, has already gone through that primary growth process to produce a new section of stem. So those are some of the features that we can see along our little woody stem here. Let's see. Another structure that I want to add to this are something that we call lenticels. And lenticels are going to be pores in the bark for gas exchange. This is kind of like the bark equivalent of those guard cells or stomata. Right, so lenticels are going to be pores in the bark for gas exchange. We can see them along our woody stem. Their shape is going to vary. Sometimes they look like little lines or eyes along a woody stem. I'm sure you've seen them before. Maybe you didn't know what they were, but those are just going to be pores in the bark for gas exchange. So that's something we can read, along our woody stem. Well, what I'd like to get back to here is that really the tip, right, or the terminus of our little woody stem here. What I've modeled up here is what we call our terminal bud. And remember, we're imagining this in wintertime. And so that terminal bud is going to be dormant because the plant isn't going to be actively growing during winter. And what we're going to find is buried deep within this terminal bud is where we're going to find our shoot apical meristem. Now you already know how roots grow, and you know that we can trace all cells in the root back to the root apical meristem. Well, the same is true in the shoot, except we're going to be tracing it back to the shoot apical meristem. So shoot just means that we're above ground, that we're in the shoot. Apical just means it's at the tip. And remember, whenever you see that word meristem, you should think lots and lots of mitosis, lots and lots of growth, right? Because that's what that terminal bud will do. We'll talk about this in just a little bit, but that's where we're going to get elongation. That's how we're going to get new sections of the shoot being produced by growth really in that shoot apical meristem. Well, remember, we're imagining this woody twig in the wintertime. And so our shoot apical meristem is dormant. It's not actively divided. It's not actively dividing. And it's usually covered up by these protective structures that we call terminal bud scales. And so our terminal bud is going to be covered by terminal bud scales in winter. And that's just to protect this area for future growth, that little shoot apical meristem. Well, what will happen as our plant transitions from winter to spring? Those terminal bud scales will fall off, and that little shoot apical meristem will start elongating and start growing. And it turns out that when all of those little bud scales fall off, there are going to be another series of scars that we can find along our stem. And so I'm just going to draw these little circular scars. We'll look at some in just a moment. Right, little circular scars that we can find along our stem. These are all terminal bud scale scars. Well, the really cool thing about these is that you can use these terminal bud scales and this kind of counting from moving back from the shoot apical meristem backwards to age a section of stem. Now, I'm sure you've seen those big old woody stem cross sections of giant woody stems with growth rings in them. All right, and you're familiar with the idea of aging trees by counting growth rings. Well, with woody twigs, you can age a section of branch externally by looking for these features, by looking for those terminal bud scale scars, because they're going to tell you where that terminal bud was. In this case, 1 year ago, that terminal bud was here, right? And this represents a new section of stem that was produced in that year. 2 years ago, our terminal bud was here, right? And this is 2 years of growth, right? 3 years ago, we get back to there. In my little model, we've got part of a 4th year, but we don't know what else is beyond that, right? Because we don't have the whole tree, we just have a portion of it. Well, what I'd like to do is just really quickly show you some real pictures of this to kind of get an idea of it before you come into lab and practice it. All right, here we are, we're in the forest, it's wintertime, and you can see all of these leafless trees, right? All those leaves have fallen off. Well, here's a couple of drawings, right? These are just models of what this might look like in 2 different species. What I like about this is that I can see, here's my leaf scars. Notice the shape of them varies. Notice that the number of vascular bundle scars and the shapes of those vary between species. We can also see those lenticels, those pores in the bark. For gas exchange, those are going to vary. Notice this stem over here looks a little bit hairy, right? It's got some trichomes on it, whereas this one isn't. Right? These are all of these scars, all of these external features that we can use to tell different plants apart. Well, let's just look at one real live plant. This is one of my favorite California native trees. This is the California buckeye. There's other buckeyes that are found in different parts of the United States. Maybe you're familiar with Ohio State, they're the buckeyes. We have a different kind of buckeye that's found here in California. So I love these trees for a lot of reasons, but one thing that I love about them is they've just got really, really beautiful twig morphology. And if we start with this photo right here, we can see the tip of a branch. Check out this. Right? This is that terminal bud in winter, and the bud scales are so big on buckeye, you can see the individual ones, right? There's one right here, another one right here, another one right there, that are covering up that little shoot apical meristem. Well, if I scan my way down my stem, that I can find my nodes and internodes by looking for where those leaf scars are. Right, I can see a leaf scar right here, part of one right here, and look, ooh, I see an axillary bud right here, an axillary bud right here. What does that mean the leaf arrangement is in buckeye? Can you tell me? All right, well, here's our buckeye, right? This is our buckeye in winter. What's going to happen in spring is that the bud's going to swell. Those terminal buds, bud scales are going to fall off. We can see a bud swelling in this picture right here, right? These are those terminal bud scales, and we can see our little shoot is starting to elongate. We're starting to see those little baby leaves being produced here. Well, pretty soon, those terminal bud scales are going to fall off, and they're going to leave scars along our stem. If we look here in this central photo, we can see some of those. So if you put your eyes right here, you can see these kind of circular scars that are going around the whole circumference of the stem. Those are those terminal bud scale scars that we can use to age a section of branch. All right, that's it for stem morphology now. We'll talk about how the shoot goes through this process of elongation, how new sections of stem and leaves get produced in just a little bit.